Okay, welcome back to another coding session. We're going to continue our testing of our language, Bangalang. We improved a lot of the testing in the last session, but we've got more to go. I mean, we could make lots and lots of tests. So I'm sure we can fill this session with more tests. And I guess as we go forward, you know, every time that we find a situation that has like a bad error message or something along those lines, then we try to fix it up and create tests then and there. There's this bit of code here that I noticed when we're type checking binary operators. So this is where, like we say, like if it's a bool, it's got to be this kind of operation, otherwise it's wrong. But because we say like it's got to be a bool with this, or it's got to be numerical, otherwise it's an error. Well, we're checking this. So we're checking this basically to see whether it's bool or numerical. And if it's not either of those, then it's an error. But up here we have like this stuff to check whether it's something else. And this effectively means that it's empty. So we can take that out, I think, because that's taken care of by this. So yeah, I just want to fix that up. And it also had the old crappy error message. So I just want to do that first. And now I think we'll just get stuck into some more tests, right? Fixing up some more tests. I forgot to start my timer, so it's a little bit late, but let's just do it now. There we go. Okay, so we have some bed mass tests that we can add. So let's go to tests. I think I'm just going to call them like bed mass 1, 2, 3, 4. So it's kind of like this. So I guess we're going to need to go boom, boom, 1, 2. So that's like 0, 1, 2. So I think that's 0, 1, 2. Do we have that amount yet already? 0, 1, 2 is 2, 4, 6. Yeah. So that should be that. And then bed mass 2 should be with a minus and a divide and a 4. Minus divide 4. And then we do the same 2, but we have brackets around, and that's 20 and 1. So that's 3 and 4 with brackets. And I think I said it was 20 and 1. Looks right. Binary operator divide is not valid for type atomic I8. And file bed mass. Right. So we need to make sure that for bed mass we're not doing these. So that's, what did I call them? Bed mass 1, 2, 3, 4. Can't do it with atomic integers. I need to do more research into atomic operations because I'm a little bit confused. I don't know that I don't even know if what I'm using atomic integers for is even necessary or not. So let's see. But we have an issue now in one of our tests. Line 16. We're doing an IML. An IML with a byte, right. So that's because we can't multiply with I8. And I haven't really figured out why. So that's why we have these like this. So I guess the bed mass tests with the multiplier, I think, are bed mass 1 and bed mass 3. Yeah, there's a multiply there and there. So that should, fingers crossed, work now. So we have some like if else stuff here. Cool, so that all the tests are working. So let's try and do some of this kind of stuff. This will be like in general tests. Let's put that there. Guess there's no reason for these to be indented, right? I don't know, I guess it looks kind of nice. But this one here is like not indented, so maybe we'll indent it. And indent that one. And this one. Okay. So let's say var 0 equals false. If true, var 0 equals true, and then we should just be able to assert var 0. And that tests our if. If true, maybe I'll do like an if false. And then we should be able to assert that it's false still. So that takes care of that. What is this one? Single statement. So that's without the scope. So I'll say non-scope, false and true, so then we can just go like that, basically. And that's testing a false and false single statement, so that, yeah, I've taken care of those. Okay, now if else. So we'll call this if else scope. Where are our tests here? Grab this. Sort of scope var 0. Yeah, okay, we'll call it an I8 of 0. So then it should evaluate to 1, so it should go in here. So it's like if else true. I think it's better like that. Okay, so if else true scope. So I guess we want like an if else false scope. So we go false, and then it should be 2. And then let's do the same thing, but non-scope versions. So we should be able to go like this. Like that. I guess we can test those. Looks promising. They should have been like the very first tests that happened, so we should have got some sort of assertion failed thing here by now, but we don't, so I think they passed. Yeah. So that's, I think, taking care of that one and that one. Now we're going into if else. Look at this naming. Okay. So it's like, so what are we actually testing here? Let's put the test and figure out the name from there. We put this in here. Just call this var zeros. The benefit of having like these isolated tests is we don't have to have all these crazy names for things. Okay, if else true scope. So what is it? It's scoped, but it's like if else if, but it is true, so like it's going to go into the first one still. Okay, that's that one. So then this one is where it's false, so it's going to go into the second one. So then it should be 2, so that's that test. And then it should, so I guess it's like, it's actually like true, true, false, true, oops, true, true, false, true, and false, false. So then that one should be 3, so it should go into here. And then I guess we'll do 1, 2, 3. We'll do like non-scope versions of those as well. Just be nice and thorough. So then we can put them all on one line. Like so. Yeah, I guess this is one of those, but it's a single line. I only did it for one of them. So now we're doing different sort of for loops. So let's just kick that off, but I can add some more tests while it's running. So we can go like for expression scope, maybe I guess I'd call it. Okay, that's good. Okay, I call it sum and value. We can use minus equals. And plus equals. So then sum should equal 55. And I guess we have to do this with a scope. We can't do non-scope because there's 2 statements in there. So that's that one done. Okay, now we have declaration and expression because we have these different variations. So now it's like, I'm going to call it pre, because I don't think it's actually a declaration anymore. It's actually an assignment now. But later I want to make it so that this thing in here can be any statement. So I guess it would be, what did I put here? Value. So we can do value like that. And I think that's basically it. For pre-expression scope. And now here we're doing like all three of them. I called this an assignment. It is an assignment at the moment, but I want to make that a statement as well. So I'll go like pre-expression post. So that would be, unfortunately, we can't do the plus, we can't do minus equals here yet. We can do that. And I can do a non-scope version of that. So that's this done. Yeah, and that's the non-scope version. And then it should be valid to declare something after. So let's put that in all these. So anywhere we have this, we should be able to go like this. I'll just put a thing to say like that the variable up here should not be in scope anymore. I should be able to read. But this, like, the way I have variables now, it's actually like, well, I do want to make it, it's not a thing right now, but I do want to make it so that you can only supply a type when you're first declaring a variable. So I'll leave that there. I don't think it's actually a thing right now. But I can leave that there. Like, we can give it a different type even, you know. So declare a Boolean. Okay. So that takes care of that. So that's all of our like for loops. That's all the tests we did for for loops. And there's some procedure stuff here. So when it comes to like returning stuff, I want to do that with every type. So I want to make that like a value thing. I want to make it like a value thing where you can pass in whatever kind of value and you can also return whatever value. Okay, so let's go to our value tests. Proc param. Let's say proc param scope. So I'll say proc 0 is a proc. It doesn't actually return anything, but param 0 is of type. And then within the procedure, we should be able to assert that param 0 equals value 0. And then we should be able to call proc 0 with value 0. Like that. Does that look right? I think so. Yeah. Okay. Let's make a non-scope version. So then that would just be like this. And then there's these were like returns. So we have like Let's do a wait, did I just change that to what it already was? Let's do a return scope and a return non-scope. So this is where I say type and then return value 0, and then I assert that proc0 equals value 0, like that. And I want to do an expression only version where I don't actually say return. I'm a little bit confused here. So I think I changed the wrong one. That's param non-scope. That's return non-scope. We're doing the returns, and this is return non-scope expression only. Yeah, okay. I think that's right. So now our test file is like, we don't need it anymore. Whoa. No, this one is the one we delete. Okay, this one we definitely need. Okay, so we're testing more than we were testing before. We've still only got positive tests that we're doing. Okay, so we do have an issue though. Where is our issue? It's byte size of a type node, which is type number. Yeah, so we do have an issue here actually. Maybe we can try and fix this up. Return values is something that we do have. I'm really not sure how to properly deal with them. But here we know the return value, right? Here's the most kind of simple one. So we know the return value, and we're returning this value. But if this value is just a number, I think we're not coercing it before we return it. I think that's the issue. So in type checking, type check return, which is not somewhere we spent a lot of time, we verify that there is a return value. This is what I want to kind of fix up. But then we don't, we do type check right-hand side expression. So we do type check it against, okay. The expression node, we do type check against the expected. So this is the return node. So I do actually feel like that's kind of right. That should, because we're using type check expression, that should coerce the type, and expression node should end up with the correct type, not just number, I would think. Unfortunately, there's probably going to be quite a lot of So the statement is return children as an identifier, address I64. So we're talking, this is standard lib stuff. Yep, that's all standard lib. Length. Yeah, this still looks like standard lib. Yep. It's going to repeat that like for every test. So that's not really a good way to get the information we want. I do feel like this is, so if we're expecting a type node, it should coerce our node to that type. We should end up upgrading types. And it should, assuming that it's like the issue that I think it is. I should have done debug. You know, in all these tests, so there's no returning here. There is a return here. I wonder if it's this expression only. Maybe I made an error in there and it's not. Because I think I might do the type checking before wrapping it in a return node. Yeah, it's going for a while now. I think it's gotten past. Yeah. Okay, so it's this expression only business. If we don't supply type information here, it's not inferring it from here. So this is part of type check assignment. Where was it? Type check assignment? Yeah, here we go. So we're wrapping with a return node. If we feel like that's what we need to do, we've already type checked the statement. So we've already type checked it all. Which should have added number and then and we needed to type check it. Why did we need to type check it? Because we need to get this. The type result of that type. Because if we're not returning anything, then we shouldn't wrap it in a return node. That's the thought. But there's another way to determine that, right? We've got the parameters type node. We can also get the return type node. You know? It should be that one. So if there is a return type node, we grab it. Otherwise there's nothing. So if there is a return type node, and we're not, oh, this call should not be one of these, I think. And the right-hand side node is not one of these. Yeah, so basically it's saying if the right-hand side node is just an expression, then we wrap it in the return. Yeah, that makes sense. If it's a full statement already, then we don't wrap it. But if it's an expression, we wrap it. Yeah. And there's no maybe I could add one, but there's no node that explicitly says this is an expression. So we just check that it's not anything else. But the benefit of doing it like this is that now we should be able to move this down here. And so it'll type check it after it's wrapped. And that should mean that this picks up the correct type information. Let's see what happens. So we do type check return values. So that's good. The thing that I want to do with return values is make them optional. Like when you do a return statement in a procedure that doesn't return anything, you should be able to just say return and not have anything after it. But my grammar at the moment, see, it requires an expression after the return. That's the problem. So we need to try and fix that. I'm a little bit worried. I was going to say I'm a bit worried about how long this is taking. It takes a very long time. Wow, and it's down to 200 frames. I do think that my laptop, I don't know. I think my laptop might have issues because sometimes it's like up at 1200 frames and now it's down to 200 frames. It's a bit of a worry. Performance is not reliable, it seems. But that's a whole lot of tests that we added. I'm pretty happy with that. We did have some ideas for some negative tests, I think they were down here. Or, yeah, if you do some things wrong. The tricky bit about that is that I don't know how to get the output of a program. When I exec, I'm just getting the exit status and see how complex this is. So I think I might go away and do some research to find out how to get the output of a program when I execute it. And then we can come back and implement like these negative tests. And I'm sure there's a bunch more that we should do as well. But I'm satisfied that we have more tests than we did before. And actually we haven't got any tests for slices or structs. We should probably add some tests for those. I guess the question comes up, do we want to test like standard library features? Or is it purely just language features? I think for now we'll just do language features. So what I mean by that is should we test that thread pools work properly? But thread pools are not like features of the language. They're just something that I implemented using the language, you know? But structs and slices we should do, I think. So we have all these ifs and fors and okay. Declare then assign array, declare then assign pointer. Let's go declare then assign slice. So we should be able to say like this, and then we should be able to go var1 equals var0 2 to 8, I'll say, and then var1, so it starts from 2, so 3, 4, 5, so I think it should be like 3. Declare then assign slice. Would there be anything else that we do with a slice? We've got pointer to array. Say pointer to slice. So var1 again can be this guy var2 can be a pointer to that, and I think we said 3 is the index. And there's more complex combinations, like slice of arrays. Or I guess first we can say like array of arrays. So we can say var1 is an array of 10, 10, 10. And then we can say 5, 5 equals that. And then we can just verify that 5, 5 equals that. So that's an array of arrays. So we can declare an array of arrays, we can assign to an index and extract an index. Maybe like a slice of slices. So we'll take this one. So here we have a slice of slices. I don't know if that's possible actually. So we can have a slice of arrays. We can do that. Can we? A slice of arrays. So if we start with a 2D array, let's do that again. And then we slice into that. Then we have a slice where each element is an array. Yeah, that's a slice of arrays. I think that should work. Can we have an array of slices? I think that's also possible. But it gets tricky to declare that. So maybe I'll just leave that for now. Slice of arrays. So that's added a few slice. This is just 2. A couple of slice tests. And I guess structs. Can we do a value test with a struct member? I guess we can. Arrays, slices, pointer, pointer to array, pointer to slice. I'm not going to bother doing like a pointer to like a slice of arrays. I think that's going a bit far. So all the tests are happy. So if we say declare, then assign struct member. So if I say var0 is a struct with member0, I'm going to put 2 members in here. And then we can say, then we deal with member 1, because that will test that we're offsetting correctly. Well, I guess we need to say like member 0, member 1 is value 0, value 1. And then we maybe test both of them are what we expect. Declare then assign struct member. Yeah. Array of arrays. We can do array of structs. This is so weird. Can I do this? Maybe I can. And then we put like index into 5. Is that a thing? It looks so weird, but I think it will work. I mean, we can type alias this if we want, but no, it should be, that's an array of structs. That's an array of structs. That should work, I think. I mean, again, it looks weird, like normally this would be type aliased, but type aliasing is something we can also test. Failed to parse file, declare then assign array of structs at line 4. I think this is a line, 1, 2, 3, 4. Failed to parse primary. I don't like that error message because it doesn't tell me anything. Line 23, so it's here. So do the value tests have a value 1? No, they do not. Value 1 can be 2. I think that's what the issue was. What did I just think of as another test? Type aliases. Could not determine type of member 0. Really? I assume this one is all good. I'm kind of assuming that it's this one which is an issue. It's an array of structs. Yeah, that is a bit weird what I've done there. It's not something I've tried before. Line 3, column 13. Yeah, 1, 2, 3. So I can't figure out the type of that. I think it's that one. Let's just comment that out to make sure it's not the other struct one. This takes so long now. Yeah, it definitely motivates me to do the importing side of the language, importing different files, of which the standard library would be one of those files, and then only processing things that actually get used. Mostly that's to say procedures. Only process procedures that actually get used. I think that will reduce the time that it takes to do the tests by a lot. Okay, so it is this test here, which to be honest, I'm not surprised doesn't work. Let's just put a to-do there. I'm not sure if that's legit syntax even. It looks really strange. Declare and assign. You could just do a declare, right? And then that should equal nil. But I don't think you can put nil in there, can you? I don't think you can compare to nil. Not with a floating point operation, you can't. But I would like to have that there. I kind of would like that you could do that, and that would, I guess that would be false, and it would be 0, and it would just be anything is zeroed out. I'm going to put another to do for that. And then maybe I'll put it right at the bottom of these value tests. It's a bit of a weird one, but type alias. So it's like type 0 equals type. And that should work. And we should be able to do it for like arrays and slices and structs. Type alias array. Should be able to do that. Type alias, and then declare and assign struct can become, well, slice, I mean, can become type alias slice. Just add this here. No. Yeah, so type 0 becomes the slice type. And I'll just put that there explicitly, and that should work. And then declare and assign struct member. Call that type alias struct. This is where you would really want to have a type alias, right? You don't want to type this whole thing out all the time. Like that. Try those. And we're about 45 minutes in. I'm kind of thinking that's like enough tests for now. Type alias slice at line 2. So that's 012. Because, no, what's wrong with that? Line 2, column 18. I don't know what that would be. What would be the problem with that? So it's like failed to parse primary. Parse identifier. This is primary here, so it's oh no, it's struct type call. This is primary, so failed to parse primary. What is the issue? I'm thinking once we get this nailed, I'm going to move on to maybe just like there's some little things just in the code that I want to clean up a little bit. So we have a bit of time, so maybe it's a good time to try some of that. Or maybe if this doesn't work, I can just put some more to-dos. So we have an if node. What? An if node? Does that just happen to be like the top? That's the first one. This is one of the things I want to clean up. So I think it's a node that hasn't been given a type yet, which makes sense because the type gets assigned within here. Yeah, so it's I guess it's more that we need to know the token. It's like we need to peek that token. Find out what that token is that we're looking at. And while that's running, so let's make that our first thing that we do. Basically, anywhere where we have an enum. So this one is already done. It's lowercase, and it has a none at the start. So see how that one, it said it was an if node. It says it's an if node, and I'm like, what the hell? It's because it's uninitialized, and that just happens to be the first one, so that effectively it's like this, 0. So if we go none, now that becomes 0, and then it becomes obvious because we come into here and it's like type none, and it's like, okay, it probably hasn't been initialized yet. It's more clear. So we're looking at the right-hand side, closing square bracket. Okay. Yeah, I'm not sure why that is, but I'm just I think it's this type alias, so I'm just gonna put a to-do here, and we'll run it again and see what we get. Hopefully this struct one type alias works. We've done type aliases of structs before, so I think it should be fine. And while that's running, let's do the boring job of converting these all to, oh, error occurred. Can I not do that while it's running? Maybe not. So primary type is fine. This one we need to change. This one's fine. This one we need to change. And jump type. Oh, this is my interpreter. This is a different project. So it's the token type and the AST node type. Those are the things that need to change. And this thing's been going forever. I think it's going to succeed. Yeah. 100 frame. My God, it's slow though. What the hell? Rename if is it because it's, can I not just change the case? What the hell? I'm going to close this. Whoa, looks like we've still got a few windows open that never wanted to close. Maybe it will help to close those. And we'll go back into CLion. Hopefully it's got its act in gear. IDE error. Come on. Ah. Of course. It's a keyword. Might have to do like that. Probably for 4 as well. Maybe that's why it was screwing up. It didn't want to change something to if because it's a keyword. Ah, that's also a keyword. Not equal, less than. Sorry, I know this is a bit laborious. Less than or equal. Equal. Could probably do some sort of like regex maybe to convert from upper to lowercase. Multiply. Modular sign reference. Dereference. Negate. Index. Call. Type. Identifier. String. Oh, that's a keyword. Okay, it looks like it did do the rename properly. C string. Oh, that's also a keyword. Number, I don't think, is a keyword. Or Boolean. Nil is. Okay. I think in my language, now it could be just the IDE is like complaining about stuff, but the language itself does not care. I know in my language, it would not care. You know, you could call these members whatever the hell you wanted. Well, that's my intention. They could be keywords, it doesn't matter. On the other thing I wanted to do, sorry about this, but I'm really picky about these things. It has to be in order. GHI, JKL, oops, less than or equal, greater than or equal, add and add a sign, go up here, they stay there, LMN, divide will go up here, reference, go here, dereference, up here, LMN, negate, GHI, index, call goes quite high, ST, identifier, string, C string, type LMN, number Boolean will be quite high, and null LMN, null. Okay, perfect. Now tokens, it's your turn. Opening bracket, opening angle bracket, square bracket, I think it should be curly, not squiggly. We're being more serious now. Oh, that's not what I wanted. Angle bracket equals square bracket curly bracket colon equals exclamation equals. Gonna need it to have exclamation on its own at some point. Maybe I'll copy this because it seems to come up a lot. Minus equals asterisk, such a strange word. Asterisk equals backslash equals percent and percent equals period, comma, hat, arrow, which I guess to be more in line with everything else, it should be like, you know, dash, dash greater than, right? Because I always just say like what are the combination it is of basic things. Arrow is kind of like giving it meaning. What would you call it? Like semantic meaning. And now I say keyword, which is giving semantic meaning. So where is keyword actually used? Token type keyword, yeah. Yeah, it's, I guess there are some, like there's identifier. So there's kind of a mix here, isn't there? Like all these, well, directive starts with a hash. So it should be like hash word, and then there should be word, I don't know. Oh yeah. I'm not sure. We can test at some point whether it's actually an issue. I don't know if it is. Number Boolean. Booleans in this language are just bool, so that's not an issue. And end of file. And now we do the glorious task of putting them all in order. Closing angle bracket. Closing angle bracket equals. Closing square bracket. Closing curly bracket. Opening bracket. Those are all the opening brackets. And now LO, there's a colon, and equals, exclamation equals, equals, NOP, asterisk goes up here. None always needs to be at the start because it's the special 0 thing. So I know it's very unfortunate, but that's not in alphabetical order. I know how much that must bother you guys. LMN plus hat HIJ dash greater than, we'll go here. HIJKLM directive goes here. Identifier HI. Well, we get in there. We get in there. String goes here. C string. C string. LMN. Boolean goes up here. Null. LMN. And end of file would go here. Beautiful. Okay, that's all that sorted. So that was one of my tasks. I do have the text open. Cleanup. Lowercase and alphabetical enums. Done. We did these review precedents of assign operators because we did add those too. Did we do any of these other things? I don't think so. I think they are type checked, so just we need to make them optional. Yeah. Okay. Cool. So yeah, we did a bunch more tests and we made our enums. Very, very nice. Loving those enums. So I'm pretty happy with that. I think that's enough for today. Okay. And so now we've got like all the tests done. I am kind of eager to like have a go at these features. There's like a bunch of little things. Well, actually, I don't know how little some of them are, but I kind of want to take a stab at a lot of these things. Just like a few little refinements. Basically what I did was I looked through all the code that I have so far to see where I thought like, this would be nicer, you know, if it was like this or like that. Yeah. Like I wonder if there's an example I can look at. See, like this is equals false. It'd be nice if that could just be not. Also, I don't really want to have brackets there. Things like that. Yeah, I don't want to have a return type. I want to be able to just do return. That's a tricky one. I'm going to have to think about that a bit. Yeah, when it comes to parsing, it creates a bit of ambiguity. It might be a bit tricky to do. But also, you know, I'd like to be able to just do this. This was a problem with parsing as well, I think, that I just didn't bother really fixing at the time. What else we got here? This, I've got brackets around here because the way that precedence works, it might try and do this and then multiply by 8. Like, yeah. Take the brackets away from here. Yeah, there's just a few things like that that I'd like to fix up. here it would be nice if I could do an AND instead of having to have nested if loops or nested if statements. Yeah, I think, well, we have like, you know, we could do divide equals, we can do plus equals 1. That's nice, but we can take away the brackets. I'd like to be able to do index plus equals 1 here, but at the moment that's not going to fly. Yeah, so there's a bunch of stuff that I would like to do. Oh, and I would like to do literals for structs and stuff. So when I go to my example code here, see, I declare this pool. I would like to be able to go like this. Yeah, so I can give like a struct literal to initialize instead of having to do a second line. And also do that for slices. I think that'll be really useful. Anyway, that's the kind of stuff that I want to have a stab at next time, so that our language is really kind of, I feel like, a bit more refined, and then we can tackle some bigger things again, probably to do with multi-threading still, and start looking at the GPU. We're getting close to looking at the GPU. That would be great. Okay, thanks for stopping by. Have a good one. Ciao for now.